Speaking of practice exam type questions and maybe even real exam type questions, this is a great one. What are the reasons that the router 2 RID here is showing up on router 1 as 172.12.123.2? What could be the problem over on router 2? And we need to come up with a couple of ways to fix this. See, I don't like to edit stuff like that. Could it be that someone forgot to put a loopback on there? Could it be that the router reloaded and cleaned itself up as it was reloading because of a script? And that could be it. So let's go over to router 2, because I can tell you right now it's exactly what we're going to see, because this router was reloaded and we don't have a loopback up there at all. We don't have anything. So that is why we see router 2's ID being 172.12.123.2. That's the only IP address on this particular router right now. And of course I could run show IP OSPF, and the very first thing we're going to see up there at the top is 172.12.123.2. So we have a couple of options here. And what we could do, of course, is create a loopback, which I will do because we're going to want to advertise that later. But also, what we want to do, or what I'm going to take this opportunity to do, is introduce you to that router ID command I briefly mentioned before, because most Cisco commands take effect as soon as you enter them, right? We've seen that throughout the course. But you're going to have exceptions. This is networking, and this is one of those exceptions. So the command itself is actually very straightforward. Move that up just a tad. Thank you. And the command is router ID. There is a dash in the middle, and there's your OSPF router ID and IP address format. Doesn't get easier than that. So we're going to set this to 2222, and there are no options. But here's a little bit of a warning that you get, and it's not as drastic as some other warnings we've seen, like with PortFast, but it is telling you that for this to take effect, you've got to do one of two things. You either have to reload the router, or you have to clear IP OSPF process. That's the command we would have to use. And actually, I'm going to take this opportunity to demo that command, because this is not something you do a whole lot, naturally, because what's going to happen is it's going to tear down any existing adjacencies. It clears everything out and you start from scratch. But let's go ahead and put that in. And that's it. Now, you're going to get a question here, and this goes back to something else we saw in another section. When a Cisco device asks you a question and the prompted answer is no, that means you're about to do something pretty serious. And you just need to take a second, unless it's a command you've run 1,000 times, you know exactly what's going to happen. You should say, hey, wait a minute, do I really want to do this right now? Because it's giving you a little warning, hey, this is pretty serious stuff. And when I hit yes and confirm it, it's going to tear my adjacencies down. I don't mind doing that in a lab environment, but I'd be pretty careful about that in a production environment. So I put Y for yes, and we see the adjacency goes from full to down. Oh, no, even tells you Y, interface down or detached. And let's go on over to router 1. See if that comes up pretty quickly. We've got still the DR other there. Let's go ahead and clear it from here as well. And of course, we're going to get all kinds of messages, because notice that's tearing down adjacencies we don't even have on this particular segment. So let's see what happens as it rebuilds. We see the DR other there. We see the adjacency with 5 is already back. And actually, that came back really quick. Your broadcast segment adjacencies are going to come back really fast. May come back so fast that you don't even notice them. So you see two-way with router 3 there, so we're looking good there. Let me go ahead and pause this until the adjacency comes all the way up. And after a dramatic pause, you can see that we did have a dead timer expire on that neighbor 0000. I've seen that occasionally when you're doing a RID change like this, especially on an NVMe network, but you can see then the neighbors 3333 and 2222 came up. And so now we see what we expect to see when we run show IP OSPF neighbor. And again, both routers 2 and 3 are DR others. We see their priority was set to 0, so we like that. And of course, our neighbor ID, sound like Kirk Cousins, you like that. And we've got 2222 and 3333 for our neighbor IDs, which is what we expect to see. So some good stuff there, because without having that loopback on there, of course, we got to change it. I could have also just put a loopback on router 2 and then cleared the processes, and the exact same thing would have happened, but that gave me the opportunity to show you that router ID command. So we don't have to do it later. We'll do it now. While we're here, we're on router 1. Let's go ahead and run show IP OSPF again. Handy little command right here. Like I said, a lot of stuff here in the middle, frankly, you're not going to use a whole lot at this point, but it does give you your router process, your start time, your lapse time, and then way at the bottom, it's going to give you your information here about each area. And we'll see this expand as we add areas, because we're going to add quite a few. Now we've got router 1 has 2 interfaces in this area. No authentication. You see when the SPF algorithm was last executed, and then it's been executed 2 times to this point. Now again, I want to get you used to seeing this in show IP OSPF neighbor when we start seeing different segments and different roles. And we'll also see some of this as we add some more routers and areas. But again, here's one segment, and we see that router 5 is the DR. And here's another segment, and you can see that those 2 are DR others, and that is just it. So let's see. Let's run show IP OSPF interface serial 10. And this is a great command to start your troubleshooting with. Again, it's show IP OSPF interface. There's the physical and logical state of the interface itself, IP address, area number, and we see process ID, what the RID is, the network type, and it defaulted to non-broadcast on a serial interface. The cost of the interface is $781. More about cost later. Then it shows you the state of the interface, which here is DR for this segment, and the priority, and who the DR is, what the IP address of that RID is, and then it's going to even tell you if there isn't a BDR on the network. Great stuff there. And now we're up to 2 neighbors on that interface and adjacent with 2 and 3, of course. So let's take a look at our OSPF routing tables. On router 1 at this point, with the adjacencies that it has, what do we expect to see in the routing table? And I'm not looking at the whole routing table, I'm just looking at OSPF. Well, actually, I don't see anything. And the reason is, again, the networks that router 1 knows about right now, they're all directly connected. 10.1.1.0, directly connected. Serial interface 172.12.123.0, directly connected. So just because we have OSPF enabled on those interfaces doesn't mean they're going to show up in your table as an OSPF route. 2, I bet you'll expect to see something here, and there's 10.1.1.0, and that's the segment that router 5 is sharing with router 1. And of course, since router 2 isn't directly connected to this, we can thank OSPF for it. Note the code right now is simply O, because we do have quite a few OSPF router table codes. We have this plain one, then we have an OIA for OSPF enter area, which means the destination the routing table is showing you is in another area. This particular one, 10.1.1.0, it's in area 0, so it's just showing up as a regular old OSPF route. These other ones, we use these when route redistribution gets involved, so it's going to be a little while before we get to those. And you also see some IS to IS table codes in here as well, even though we're looking at show IP route OSPF. But again, IS to IS, none on our exam, but it's interesting that those codes are in there. So what we should do, frankly, is send some pings around. Let's ping router 1's Ethernet interface. That went fine. And can router 2 ping router 5? Sure it can. Now let's go over to 3. There is a reason I'm showing you this. 10.1.1.0, let's ping from here. And we'll ping router 5 from here. And let's go up to router 5. Oh, need number 4 there. I know this looks a little, there we go. And we'll run the show IP route OSPF. And we see 172.12.123.0 because OSPF discovered that for router 5. So let's send some pings around all of them to 1, 2, and 3. And there we go. So our NBMA network, a big success. We got to fix our router ID. Our routing tables look exactly the way they should, and the pings are going around as well. Now there is a reason that we just sent those pings around at this point, because we're going to be adding more areas. We're going to be adding several different network types. And the thing is, when you're building out a lab or you're building out a production network, but especially in a lab, it's a really good idea to check these things as you build an OSPF or an EIGRP network. because the more areas that you add, things get a little more complicated. And if you wait until the end of a network build to start sending pings around, that's when you can get, it's not really getting into trouble, you just have more to troubleshoot. Because right now, if router 5 can't ping router 3, then I don't have that many things I have to troubleshoot. But if I wait until I add a point-to-point network and another connection between routers 1 and 3, and then I add router 4, and then put router 3 and router 3 and router 4 in a different area, you see all of a sudden you've got more stuff to troubleshoot. So it's a really good habit to get into as you're building a lab, to send pings as you're building a network. Don't wait till you're done with the entire thing and then say, oh, okay, let's check connectivity. Check connectivity as you go along. And your voice as well. So let's see, coming up next, we are going to add another connection between routers 1 and 3. We're going to build our first OSPF point-to-point network, and we may see some of those famous network exceptions in that one. And we'll just keep on pinging until we can't ping no more. And that's coming up next.